Alright, so in this lesson we will describe the effects. So describe the effects of dilating a shape proportionally. Of dilating a shape, well, I'll just say dilating a shape. Alright, so we know dilations, or dilating, is a change in size. A change in size. So let's go ahead and talk about these changes in size. So we have this rectangle right here. It is 4 centimeters by 2 centimeters. It will be dilated by a scale factor of 3. So the scale factor, I'm going to change this to blue. The scale factor is, let's see how it compares to 1. I can draw that a little better, right? So is this 3 larger than 1 or less than 1? It's larger than 1, right? The scale factor is larger than 1. So the dilation, the new one, is also, well, it's going to be larger. It's going to be bigger than what it was, right? So the side length. So our original base over here, our original base is 4 centimeters. And our height is 2 centimeters. Since our scale factor is 3 right here, scale factor is 3. So that means we're going to multiply our sides by 3. And so we get 4 times 3 is 12 centimeters. 2 times 3 is 6 centimeters. So the side lengths and the dimensions or the dimensions of the dilation. So these side lengths are going to be 3 times bigger. 3 times bigger than the original ones. So instead of being 4 like it was here, this will be 12 centimeters. And instead of the height being 2 centimeters, it's 3 times larger, so it's going to be 6 centimeters. Okay, let's look at the perimeter. Now to get the perimeter of the original shape, right? Then we need to add up or find the sum of all the side lengths, all the outside side lengths. So let's write these out. So we get 4 centimeters. I'm just going to put 4. Like, as long as you put it in the answer, you're fine. 4 plus 4 plus 2 plus 2. And we get 12 centimeters. 12 centimeters. So just like this right here, just like the side lengths, we would just multiply by the scale factor. So the new distance around won't be 12, it will be 36 centimeters. And you can actually tell, this will be like our proof. You don't have to do this like on your paper, but we can see that 12 plus 12 plus 6 plus 6 will actually give us 36, because that's 12 plus 12 is 24, plus another 12 is 36. Let's see. I'm actually going to write proof a little bit better, because it's sort of hard to read since the line is so thick. Proof. And remember, this isn't required. This is for the notes. So like in the notes required, in the work it's not. So we had 12 plus 12 plus 6 plus 6 equals 36. Remember, we got that from this 6 and this 12. So the perimeter was also 3 times bigger. 3 times bigger than, I'll just go like that. Okay. Then the original. So this is the perimeter, the distance around this one was 3 times bigger than this one. Now this is where it changes. So let's get the area. Let's do base times height. So our base is 4 centimeters. Well, let's just put 4. And our height is 2. And we get 8 centimeters squared. Now don't forget the centimeters squared. You know what? We'll put them here. Let's change this. Okay. But this time we're not going to multiply by 3. Because, like, for instance, 4 times 2 was 8, right? But 12 times 6, like I'm gonna do this. Let's pretend it was 3. We would get 24, right? That's not gonna work because these new ones, 12 times 6 is not 24. 12 times 6 is not 24. It's just not gonna work. 12 times 6, so 10 times 6 is 60, 2 times 6 is 12, so we get 72, right? So we have to somehow get this 72 square centimeters. This is actually not times 3. This is actually, remember, see how this is second power to the second power to the second power? This is actually times 3 to the second power. So the area of the dilation will be 3 to the second power. Or, let's use decimals. I mean, I know y'all know how, but I gotta show you now, so it'll be easier when I show you later with the fraction. So let's go to scientific calculator. And we do 3 to the second power. You can either press that, or you can just put times 3. And you get, you get 9. Like 9, because that's 3 times 3. So 3 times 3 is 9, so it gets 9 times bigger. Not 3 times bigger, but 9 times bigger. Like if this scale factor was 4, it wouldn't get, the area wouldn't be 4 times bigger. The area would be 4 to the second power times bigger, and 4 times 4 is 16. So it's not going to be the same as the others. It's going to be to the second power. Let's go ahead and try another.